Save it to your power notes. It's two down from the
This is the that's just the one. What's the name?
All right, Cameron, amplitude.
Yeah.
That's actually a good question. Is the amplitude 2 or -2? It doesn't actually matter. Technically, the amplitude of this equation is 2 because the amplitude is just half of the total height of the function. But it's a useful thing to remember that, in fact, there is a negative and it is flipped over. So let's do this, just to remind ourselves when we go to graph. Macia, frequency. And Macia, how do I use that to find period? And if I simplify 2 pi divided by 1/2, I get? Cool. Thank you, Macia. Megan, phase shift.
Oh, I know this one. Oh, wait. Yeah, sorry. Right pi over 4.
We're good? Thank you, Megan. Ryan, vertical shift.
Up 3.
Good? All right, thank you, Ryan. Levi, H comma K. I don't know where any of those numbers came from. Started at 0, 0, right, Levi? And then we started moving it around. Where did that point 0, 0 move to?
Oh yeah, 0, 3.
How much did it move up? Yes. How much did it move to the right? Not left. Because that would be negative. It moved right by pi over 4. Agreed? X minus h. Agreed? Cool. Guys, we know everything we need to graph this. Thing 1. Where's the center line? Akil.
3.
How much am I going to have to go up from 3 after when I'm graphing? Where's my maximum going to be?
2.5.
Guys, that's a useful thought process to have before you actually start drawing your axes. My center line's at 3. My maximum's at 5, which means I need my graph to go up to 5. What's my minimum, Akil?
1.
1. So I need my graph to go from at least 1 to 5. I don't need anything else. Now, it's nice to have 0. I don't actually need any of that. And I'm going to draw a scale. 1, 2, 3, 4, 5 that allows me to do my whole graph. Right there. We go to that? Cool. Thank you, Akil. There's my center line. Mark, where's my starting point?
Your starting point is at pi over 4.
Okay. were you gonna say?
3. So, coordinate.
So guys, now we run into another one. How big do I make my scale here? And it's useful again to do some calculations before I mark my x-axis. Because where am I going to end? Where is my last point? Obviously, because it's a sine graph, it's on the same line. But how do I find this number here? Ryan?
It's starting by plus the period, so pi over 4 plus 4 pi.
Uh-oh, so the pesky fractions again. What do I need in order to add two fractions? Anyone?
2 fractions.
Yes, I've got them. Then what? Mark?
Common denominator.
Common denominator. How many over 4 is 4 pi?
16.
Okay, that's totally unreadable. There we go. So now I know how big I need to make my scale. I need to get to 17 pi over 4s. So I can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And 1. That makes sense? We good with that? Cool. Guys, there's the first point. There's the second point. Where's my third point got to be? Rabin, third point?
Third point's in between the two ends.
Aha! Halfway between pi over 4 and 17 pi over 4. So how do I figure that out, Rabin? Halfway between two numbers, also known as another word for halfway between two numbers.
Thinking.
I got an 80% on the first test. I got a 90% on the second test. Halfway between my two numbers is 85, and that's also known as
The average.
yeah.
That was simple.
You know, it is funny though, because we learn these math words and we learn what they mean, but we never really translate them. Somebody says, hey, what's the average of 80 and 90? And you know, I find average by adding them and dividing by 2. But if they don't actually use the word average, it's like, what is that thing? What is that thing? Because we get used to just, this number means that, but we don't, or this word means that, but we don't translate it into English in our heads. We just stick it with some formula and then boom. All right. 1 plus 17
18.
over 4 over 2 is really over 8, right? Divide by 4, then divide by 2 is the same as divide by 8. What goes into 18 and 8?
2. Oh, no, yeah, just 2.
There's my center. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 pi over 4. That's the middle. There's the third point. What? 1 plus 17 is 18. Divided by 4 divided by 2 is 8. 18 divided by 2, 8 divided by 2.
Oh, I thought you meant like 4 goes into 18. I was like, oh.
No, I totally didn't say that.
That's what
Oh, gotcha.
That's why I was confused.
Okay. All right, we good? Awesome. Maris, what's next?
Halfway between the center line points minimum and maximum.
Good. So my fourth point will be the maximum. Halfway between which two numbers? Or do I want to do the minimum? For where's the maximum? Is it here or is it here? So we got to be a little bit careful on this. Well, let's find out where it is. Let's go halfway between, see, that was 1 and this was 3. Let's go 1 to 3. So halfway between these two. What do I do?
Pi over 4
Pi over 4
plus pi, plus 9 pi,
plus 9 pi over 4.
not all of that.
Boom. So pi 1 plus 9
10 pi.
divided by 4 divided by 2 divided by 8, which is 5 pi over 4. Notice how nice it is that everything's in pi over 4s. So then I can just count 1, 2, 3, 4, 5. Right there, there's going to be something. Is it up here or is it down there? Why, Ryan? Aha. A sine curve goes like this, but a negative sine curve goes like that. So I'm actually going down. My unit circle Ferris wheel is spinning backwards instead of spinning forwards. Putting some even wear on the gears. Been going forward for a while. Turn it around and go backwards for a while. Which means that we're going to be here at, as Akil told us earlier, at y equals 1. That's our minimum. Cool. Thomas, that was our minimum. Now I need to find our maximum, which is going to be between points 3 and 2. Where is that point going to be? How do I find it?
Do 9 pi plus 17 pi over 4. Which would,
Oh, wait.
oh, divided by 2.
Good. 9 plus 17 over. Simplify. Cool. That's okay. 9, 10, 11, 12, 13. Max or min? There it is. Was that simple? That was simple. Was it easy?
Yeah.
Don't let anyone ever tell you that simple and easy mean the same thing. Guys, this is a simple process. You identify the 5 things. You draw the center line. You find the starting point. You find the ending point. You find the middle point. You find 2 more middle points and you draw your graph. That's as simple as it gets. Doesn't necessarily mean it's easy because there's a lot of little calculations that go on in there and you have to remember this and you have to remember that. It's pretty simple. Nurse.
So what's the minimum and maximum for y? Did we just take the amplitude and then the center line?
What you just said.
Okay.
Down 2, up 2.
And then how did we find the center line again?
How did we find the center line? Remember, the center line was on the x-axis, and then we shifted the whole graph up 3. So the center line's now at 3. It's just like an asymptote in that respect. If a function has an asymptote and you vertically shift it, it's got an asymptote that's now vertically shifted by that much. Questions? Macy?
So, when you were figuring out what the, with the two points,
No reason at all. Macia's question was, so for example, we're going from 9 pi over 4 to 17 pi over 4. And since they're both over 4, could we just go 9 plus 17 over 2, which is 13, and then say, oh, but it was over 4, so yeah, absolutely. No reason you can't do that. The reason I don't like to do that as a teacher is because then people say, wait, where did the 4s go? How did the 4s just disappear and then come back? It was like magic and I don't know what just happened. And so what I do is I go through the extra step of saying, I have this number plus that number divided by 2, and then I will simplify. Yeah, when you guys are doing this kind of math, when you're doing any kind of math, when you see mental shortcuts, knock yourselves out. As long as you get the right answer. Mental shortcuts are great, and I would do the mental shortcut if I was actually doing this problem myself. But yeah, if I wrote this, there'd be a significant number of people in any class I teach that I just lost them. They have no idea how 9 plus 17 divided by 2 became 13 fourths. What, Mr. Armourding? Yeah. But yeah, no, mental shortcuts are wonderful. They're what makes the world work efficiently. So, all right, nice. Okay. Next. What?
I have a question.
Ask.
Okay, so.
Hurry before I get to that part and erase it.
Okay, well, you've already erased it, but, where do you get the 2 pi from in the period? I forget. Because you put 2 pi
Definition.
over,
Definition. Period equals length of one cycle. Frequency equals the number of cycles in 2 pi. And because of those two definitions, if there are b cycles in 2 pi, each cycle will be length 2 pi divided by b.
okay, yeah.
Okay. New equation. Y equals three cosine I want you to walk through that process. Talk to your partner. Give you about 5 minutes to get started, and then we'll discuss. Think carefully about the differences. Nate.
Yep.
Grab your stuff. Come here. Excellent. Thank you.
Right. Minus 2 pi. And then it's gonna be.
Okay, wait, amplitude, that's 3, right? No, I don't wanna see, I need to get this. Wait. Amplitude 2. Where's the equation to the first one? 2?
I don't know why you would.
So the amplitude would be 3?
Yeah, sorry.
Would it be negative pi over 3?
A equals 3, right?
No, it's positive. It's x minus h, but h is actually equal to 3. So h is pi over 3, negative
This
5.
one. 2. Period. Pi over 3.
No,
Wait,
remember you do 2 pi
Oh.
over your frequency.
Oh, wait.
It's
2 pi over your frequency?
Yes.
It's really short.
My
It's
frequency
2 pi over 6.
pi over 3.
Your frequency is 2.
Oh,
So there is 2 pi.
so 4 pi.
No. 2 pi divided by 2.
Oh, so a shift to the right, negative pi over 3.
Yep.
To the left,
Not negative. No, not negative.
phase shift to 2.
It's just, if it was x plus, then you left.
Oh,
So it's just right pi.
Like, it's so easy to figure out how to.
Yeah, so that's.
and then
For
shift
like,
is
Wait,
that's all we have to do.
I'm gonna assume they graphed it.
That's a graph.
I'm gonna assume so.
Wait, HK
Oh, yeah, okay.
start with the cosine.
is
Starting like there.
pi over 3.
You said 2, the sine just starts right in the middle. Cosine starts all the way at the top.
Negative.
Really sure. I think more than that.
So now you have a
Yeah.
So,
Well, this is still negative 2, but the amplitude is 3. So the maximum of the graph would be at 1, and negative 2 plus 3.
center line,
Basically, it just starts like here. Like that.
your
It
center
just
line is negative
starts
2.
with
So you make a big graph or a tiny
And
graph?
then it comes down. Okay, wait, hold on.
Up 3, down 3, right?
Yeah, so just go. 1.
Oh my god, why
Wait,
is it so big?
look at the pyramid. I don't know. That's the y-axis.
Wait, it doesn't. Oh yeah, the vertical is 5.
On the X.
That was 3.
Over 2 over frequency.
Oh, you have to go down to negative 5?
Yeah, because you gotta go up 3 and down.
You can go up 3.
Oh, because you do.
Yeah, because up 3 from negative 2.
Basically, I think it's just like the first midpoint you
Your
graph,
center line's at negative 2.
and the one in the middle of the graph.
The center line is the frequency, right?
Center line is K.
Yeah. Yeah.
So center line's here. And then you gotta go up 3 and down 3.
I just
So
remember.
negative 5.
Minimum is negative 5.
So the beginning would be
Just wherever it started from. Or in this case, it's pi. The period is pi. So wait. Wait a second. I just did this whole thing. I didn't do it. It ends at 4 pi. It's not pi. And that's why the thing was so messed up. But it's just the starting point plus the period. It's just
How do you do that?
the period is five.
The
Five or three plus
I
five.
over 3 plus 5.
Mandatory graphics.
We did that thing?
It's 4 pi over 3. Wait, there's only 4. Here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Yeah.
I think. Could be wrong.
Okay.
Probably wrong.
How about this?
Okay.
No, we did. That's what we did on the other time. What do you think is wrong?
I don't know.
No, the thing that I don't get is how to graph it. Would it be 0, 0, 3?
Yeah, I'm doing
That's one singular pi.
Yeah.
Don't we have to go all the way to like 3 pi?
So that's pi over 3 right here.
Oh, then we have to go to 2?
Well, I'm gonna go.
Yeah.
But if your endpoint is
Add them
right
and then
here,
divide by 3.
Wait,
Right
that's our
here.
endpoint?
yeah.
Our endpoint is pi over 3, isn't it?
The period is right
4 pi
here.
over 3.
4 pi over 3, that means we have to go 4.
No.
If we're making each one of these pi over
Here,
3,
so that means
If these were all separated into threes, it'd be 1, 2, 3.
oh, that's what we did.
Yeah.
But like, we're not like pi over
So
6.
each one of these, like,
Two boxes is 1 4.
one is like a third.
Oh, we're separated into 1.
Yeah. That's
Two
just what I
boxes
did.
is 1 there.
That's just what I did.
Pi over 3, then divide by 2. That's just
And
saying
then
5 divided by
your
6.
first
You divide by
thing
3 and then divide by 2.
right here.
And then that thing divided by 2. So the whole thing was just 5 divided by 6.
Okay. And you're halfway.
Right, that's because.
So the starting is at
period plus. So the endpoint for us is.
pi over 4.
Pi plus. Pi over
Uh-huh.
Oh, so starting is pi over 3 negative 2.
Wait, so they did what?
Pi over 3 negative 2 is the starting point?
Yes, yes.
Find the.
That's the starting.
Find, wait, you find
The ending point
the endpoint was.
would be 4 times pi.
Oh, never mind. So I think
The
that.
ending
Versus this
The
one.
ending point would be like 6.
or the.
I messed up my scale. I'm gonna fix it, but.
Oh,
I'm-
I messed up. No, yeah.
I'm getting a half.
It's actually
No,
over
that's the halfway between what you never had to do.
basically what you do is like, so half of this is pi over 6, right? So pi over 6 is like right there in the middle. You can go 1 pi over 6, 2, 3, 4, 5. Pi over 6 is there.
Wait, yeah.
And the
Yeah,
other-
but we have it in third, you see.
Yeah, but you have it in fourths here.
And then you put it
Or
in
right
the
next.
eighth,
Yeah, so that.
and then when you, then you
Then you have
divide
to simplify.
it by 2, so it's 2 and
Yeah,
a
the
half
middle one is
thirds.
5, 5, 6. Which is,
I mean, you could just do
yeah,
it.
that's where it is.
1, 6, 6,
Find
6,
the
3, 6.
points.
That's very simple.
That's
That's very
very
simple.
simple. Find the points between that and that. Because we can just take the average of the.
And how hard are you to save there?
Yeah, that's the half.
5 over 3 plus 5 over 6.
Why is mine never halfway? I think it's not.
How did you even?
No, because look at this one.
Oh,
Oh,
no,
never
never
mind.
mind. You can just change this to 2 pi over 6.
And then to get this point,
That's the halfway, we have to find
we have for your minimum.
12.
the minimum.
Minimum. Wait, no, you gotta do pi over 3.
Yeah, 5/6 and now over 2.
So pi over 3 plus 5 pi. So this is gonna be real annoying.
And that's the max.
5 over 3.
I mean,
Plus
That's
5
actually
or
you're gonna cross the center line. See, it says in the middle, it actually goes down and crosses it there.
because you have to have common.
Like behind you though.
7 times 12. So
Which is
1/12
just
is 1/4 of a third. Like 1/4 of 3. So 6. This is 3 here. 1/12 is 1/4
So
of that.
that's just.
Basically,
I messed up.
each.
I did too.
1, 2, 3, 4, 5,
Oh wait, no, because it's minimum.
7 is
Because it's
basically 3 plus across that box.
And then the last one,
Like that's the point where it's that's the point where it crosses.
find the maximum.
Oh, yeah.
That's down.
Give me a second, let me do this.
that's fine.
But that's how that
You don't
Let me do
know?
it, let me do it, give me a second.
You don't know?
Give me a second.
Yeah, so it does. It's like over there. See, it goes down there.
Maximum
And
5.
the point where it crosses again is the other section.
Oh,
With the average of this point.
the minimum.
I would agree. I mean,
Remember the minimum.
Okay. Wait, no, the minimum, no, the maximum would be 5,
Yeah, 5,
negative
6.
minus.
And you have the.
You have to do your halfway point plus your midpoint.
The first one is these two, and the second one is these two. The minimum
Yeah,
is
to get the
these two.
minimum,
These
so this one would usually be the maximum, but since it's,
Flip.
wait, it's not flip,
It's 8
it's not flip,
Then
flip it,
that's 1 thing divided by 2. And this is
it's not flip.
Exactly, so it was right at the
You
beginning.
were right, I'm sorry.
But then if you do the same thing, then just come down to 5 and 3.5, right?
I mean, yeah,
Then why are we even doing calculations?
because, so,
That's weak.
That's a 4.
this is so, yes.
No, I'm actually pretty sure it's a diagram. I'll just click on it later. I think it is. So 35 and 12.
Wait,
Oh, I see what you
it's, wait, it's 6.5, right?
All right, here we go. Jetsi, amplitude. Agreed?
Yes.
Thank you. Rosny, frequency. And if the frequency is 2, what is the period? 5 divided by frequency. Okay. Thank you, Rosny. No, not here. Not here.
Both Ben and Lee.
Maya, phase shift.
Pi over 3 to the right.
Thank you, Abilene, vertical shift.
Down 3.
And Abilene,
Pi over 3. Comma 3. Negative 3.
good.
It says -2 there.
Oh, I can see negative. I wasn't even looking. Abilene, do you agree? Do you say 2? I thought you said 3. Good. All right. Carson, center line.
Y equals -2.
Carson, what's the maximum and the minimum going
I
to
mean-
be?
The maximum is 4 pi over 3.
No. The height. The height, how far up?
Oh,
I'm drawing my scale. I need to know how far up I need to go, how far down I need to go.
would it be x equals -2? I'm confused what you're asking.
So I'm going to draw the line y equals -2 on my graph as my center line, but I need to know how far up I'm gonna have to go to my maximum and how far down I'm gonna have to go to get to my minimum in order to actually graph it.
Okay. Oh, we just wrote down 2 for our max and then -5.
What's that?
No,
No.
-5.
How do you get 2 and -5?
Because you take the center line, and then basically the amplitude is 3. So then you go up 3 and then down 3.
So up 3 from -2 is 2.
Oh, it's not 2, it's 1. My bad.
It's okay, we all make mistakes. Once I thought I'd made a mistake, turned out I was mistaken. Guys, this is a useful step. It's a useful step because when I draw my graph, I need to know where to put the scale. And I now know that I need to go up to 1. And down to -5. And now I can draw my center line right there at y equals -2. My graph is going to cycle around that line right there. You don't have to do this, but the awkward part is that if you don't do that, and you just draw yourself a graph and then discover that it goes down too far, maybe you don't have room. So it's useful to think about graphing in advance. Where do I need to be? Where do I got to go to? So now let's do the left-right direction. First of all, where am I going to start, Nate?
I think that you're gonna start at negative, no, not -2, because you don't say that first, so that's not right. You start at pi/3, -2.
So right now, all I care about is pi/3, and then we'll come back and talk about the rest of it in just a second. Because the next question is, where do I end? Nate, where do I end?
Wow. You would end at 4 pi/3,
How do you know?
because it is the period, which is just pi, which is 3 pi/3, and plus pi/3. -2.
We'll come back to this in just a second, but for now, what I know is that I need to go all the way to 4 pi/3, and I want to go there in units of pi/3s. So 1, 2, 3, 4 pi/3. And now I'm set up and I can start thinking about graphing. All right. Let's talk about the -2 on both of those points. Anybody see any issues with that? Ryan?
Are those points like the minimum and the maximum?
Why?
Because on cosine, like it would start, since it goes from the circle, it's the x-axis. It starts all the way out one side. It goes like that way the whole time, and then it goes back the other way. Like, okay.
The graph of cosine starts at a maximum because it's this distance here
So it
and
goes
gets
to maximum.
smaller and smaller and smaller until it reaches a minimum over here. Gets to 0 right there and 0 right there. So Ryan is absolutely correct that it starts at a max, goes through 0, goes to a min, goes through 0, and then goes back to the maximum. So when you're graphing cosine, we don't want to start on the center line because cosine doesn't start on the center line. Sine does. That's the difference between the two. Sine is your vertical, and it starts at 0 and goes up and then down and then down and then up. Cosine is your horizontal. It starts at a maximum and then comes down to 0, over to negative, back to 0, back up to the maximum. Does that make sense to everybody? So instead of starting at -2, Nate, where's cosine going to start?
I think
It's starting
it's
at,
going to start at 1.
and it's going to end at
1.
boom. Pi over 3, 1. 4 pi over 3, 1. We good with that? Make sense to everybody? Yeah.
When we write h comma k, we wrote pi over 3 comma negative 2.
We sure did. Was
So-
that right or wrong?
So would we should just take that out? Like,
Well.
we don't,
What would k be in this case?
well, I thought it'd be positive 2. Negative 2, but then we switched to 1.
So let's talk about the locator point for the parent graph of cosine. Where's the locator point for that parent graph? Can't be 0, 0, right? Because 0, 0 is not even on this graph.
0,
But k is not really a point, it's a parameter, right? What do you guys think? Where's the locator point for cosine? Eli? Double-handed volunteering to answer a question? I like it. I love the enthusiasm. Eli, where's the locator point down there? Where's a really awesome point that you look at that graph and you say, hey, look, there's where it starts and that's what I'm going to move? I know I really put you on the spot, didn't I? Because you were just stretching.
Pi over 3, -2.
Yeah, but that might be true for our shifted graph. But right now we're just talking about the parent. Guys, remember that locator point is some useful, interesting point that we look at, like the vertex of a parabola, and say, when I'm moving this thing around, I'm just going to move that point around with my transformation. And on the sine, we said, well, hey, look, sine starts at 0, 0, so let's just make that our locator point. Because wherever we move the graph to, that 0, 0 is just going to move around, agreed? Where's the obvious point here?
Zero and then our max.
0 in the max.
Like, how do we know what the max is on? Oh.
It's cosine. It's a unit circle.
Yeah.
Can't be more than one. So you get to say yeah, but I still answer questions, even if you yeah them as But I love it when people figure out the answers to their own questions before I even get a chance to say something. Yeah, guys, 0, the max is a great locator point. Why not? So what are we going to put in here? Jesus.
Wait, so is the max for cosine always going to be 1?
Well, it is for the parent.
Yeah, for the parent, it's always going to be 1.
Has to be, doesn't it? Unit circle. Cosine is defined as, hang on a second, let me get my colors out here. Cosine is defined as this length right here, wherever I am on the circle. Sine is defined as this length right here, wherever I am on the circle. So cosine cannot be greater than 1 because the furthest away you can be is here. I'll get to you in a second, Macia. And it can't be less than -1. And sine cannot be more than 1, and it cannot be less than -1 until I stretch the circle, until I do a transformation. Because as soon as I multiply this whole circle by 3, now cosine can go from 3 to the right to -3 to the left, agreed? And sine could go from 3 up to -3 down. But then I'm going to move the circle around as well because I got a shift. I'm moving it back and forth. I'm moving it up or down. But my circle starts in the middle and it goes up to the top and down to the bottom, if I'm talking about sine. And my circle starts in the middle, starts at the top, if I'm talking about cosine, it goes down to the bottom and then back up to the top. Because of those definitions, cosine is this length, sine is that length. Mason.
So, is it the locator point, where the graph is based on? Like, it doesn't necessarily have to be on the graph.
I couldn't hear a word you said. Sorry. Masks, me. One more time.
Is it the locator point with the, like where the graph is based off of? Like, instead of, like, it doesn't have to be on the graph, it just has to be like where it's based off.
The locator point doesn't have to be on the graph, but it depends on how we define the locator point for any given function. Locator point of a parabola is always on the graph. Locator point of an absolute value function or a square root function or a sine function or a cosine function is always on the graph. Locator point of a hyperbola is not on the graph because we define it as being where the asymptotes cross. But for sine and cosine, if we're going to define the locator point as wherever the graph starts, 0, 0 for sine and 0, 1 for cosine, it's going to be on the graph because when we transform 0, 1, in this case, 0, 1 gets moved pi over 3 to the right, making it pi over 3, and then it gets stretched and moved down, leaving it at 1. Does that make sense? Jesus, go. Guys, locator point is just one of those things that you don't really need to know where the locator point is, but it sure does make life a lot easier. If you're graphing a parabola, do you need the locator point now? You could just find a whole bunch of points and stick them on there. But the nice thing about the locator point is, because parabolas have symmetry, you're going to go like this. Here's the problem with not knowing the locator point. If I just had a whole bunch of points on a parabola, what if I had this point and this point and this point and this point and this point? Where's my parabola? I don't know. Is this the vertex and it goes back up again? Or is the vertex over here? The locator point lets me know that it's okay to stop plotting points because I've got symmetry and now I know where the parabola is. If you don't know the locator point, you have to do a lot more work. I could just keep plotting points until I saw it curving back up again. But if I know the locator point, I know that I can just stop and go right back up. And symmetry says I can just go boom, 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 and I don't really have to do any work. The point of the locator point, the purpose, because that was awkward, point to locator point. The purpose of the locator point is to make your life easier. Because if you know where the locator point is, you know what the graph looks like for all of these functions. Do you need this locator point? Not particularly. But it helps sometimes because when you think to yourself, wait, the locator point's on the center line for sine, but it's at the max for cosine. you won't get it wrong. You'll know looking at a graph that, oh, look, this is a cosine graph because it's starting at the top. Oh, look, this is a sine graph because it's starting in the middle. So it's purely a convenience that makes your life easy. And we can define it any way we want. We didn't have to pick 0, 1 as our locator point. We can pick anything we want. But a starting point is sort of a nice, easy place to have as a locator point when we're dealing with these trig functions. Cool? That answer your question? Yeah. All right. I'm going to guess that most of you have a picture of a sine graph on your page, huh? Or a lot of you? Yeah. Yeah, we do have to remember cosine and sine different because of the way we've defined them as the vertical distance versus the horizontal distance on our unit circle. All right, I've got my start. I've got my end. Macia, what's next? And that third point is in the? Good, how do I find it?
You find the average and
See what I did there? Just for Macia. Uh-oh, it sort of backfires on this one, doesn't it? 1 + 4 divided by 2. Oh, I'm so unhappy right about now. So horribly unhappy right about now. Mental tricks aren't always good. And in this case, when we did the mental trick, we actually made our lives harder. Because we ended up with either a mixed number or a decimal in a fraction, which doesn't make life easier. So we need some pi/6s, so I'm going to add to my scale. There's a bunch of pi/6s. 1, 2, 3, 4, 5. There's 5 pi/6. Macia, where do I find that middle point? At the minimum. And look, I just left myself just enough room above my writing to put a dot there because I'm a trained professional. Anybody think about being a teacher? Because you too will become a trained professional.
If I ever became a teacher, I feel like I would do like a different character each year.
What?
Yeah.
Nice. I like it. I like it. Plan ahead. Yeah.
Like the first year.
All right, but no. Don't tell us the details. Don't tell us the details. Megan, what's next? Okay, Maris. Do not allow yourself to be distracted. Megan, go.
Well, it would be the minimum and the maximum if it was sine, but now it's cosine.
So what comes halfway between a maximum and a minimum? Yeah, a center line or a 0.
0.
Yeah, we'll call it center line. I mean, it's a 0 when you think about the parent graph. So it's going to be on the center line. How do I find it, Megan?
You do the first maximum, so it would be pi/3 plus 5 pi/6 divided by 2. Do you want me to?
Yes.
Oh, okay, sorry. Well, I changed it so it was 2 pi/6 instead of, yeah. And then it was 7 pi/6. That's 6. That's 12.
feel like I'm missing something there. Oh, I didn't put a pi over 6 there. Oh, shoot. Yeah, I did. Yeah, no, we're good. 7 pi over 12, 1, 2, 3, 4, 5, 6, 7, right there. Comma, -2. I like it. I like it. Akil, last.
5 pi over 6 plus 4 pi over 3 divided by 2. And that turns 4 pi over 3 to 8 pi over 6. Then I get 13 pi over 6 divided by 2, which is 13 pi over 12.
Cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 13. I don't know why I said 14. I just kept counting because I was having fun. You know why they call me the count? Because I love to count. Come on, we've all seen Sesame Street, right?
No,
No?
that's the one with Jack Black,
Oh
right?
man, yeah.
No, that's
Oh, Nate.
Oh, he was in it. He was like,
Oh,
wow,
Nate.
octagon. And then he pointed at a stop sign.
Oh,
I
Nate.
watched that one.
All right.
I have a good memory.
Now, graphing. I don't think Jack Black was alive when I was watching Sesame Street. I'm pretty sure he's a little younger than me. So he wasn't in my Sesame Street, and it was the better for it.
Born in the 60s.
All right. Guys, here's the next thing. This is a maximum, right? Here's where people have a tendency to get sloppy and lazy. And I will have no sloppiness or laziness in people I have taught, because then it reflects poorly on me. That is not a cosine graph, because you can't go above a maximum, right? So when you graph this, you need to go up and curve over and come back down again. Please come back down again.
Now it looks kind of like a
This is
bird.
upside down, Megan.
Draw bird.
No, it's not.
Yes, it is.
No, it's not.
Oh, no, it isn't.
There you go. There's a graph of cosine.
Is yours upside down?
No, mine isn't even done.
We've been doing it together.
I know, but my graph is messed up. I need a copy.
Questions?
How did
I extended it so that every 4 is there.
All right, guys. Notice that the process is the same every single time, just like everything else we've done. A lot of math is process. You look at a problem, you figure out what kind of problem it is, which then identifies what process you have in order to solve it, and then you just work your way through the process. The hard part is identifying the process a lot of the time.
Yeah.
Then the rest of it is just plug and chug, plugging in things, plugging in numbers, chugging your way through the process. All right, can I erase?
No.
But I want to.
I
listen to
don't know, can you?
Well played.
I don't know. You did that to me about math. My homework.
I know. That's why I was saying that was well played on Nate's part.
Touche.
Mark,
Can I go get my water bottle?
really, Mark? We just had this discussion.
I don't know, can you?
I don't know. Anything wrong with your legs?
May I?
Yes, you may.
That's a good one, Mark.
Thanks.
There you go. He's gone.
Man, it's such a pretty day.
It is.
Water bottle, Mark.
Oh, I thought you were talking to
He
me.
doesn't want to trip on his shoelace on his way, so.
I was like, thanks, I guess.
All right, I am erasing, whether you like it or not. Yeah, it is. Because now we,
That's hindering my learning.
and what else is hindering your learning? Oh, I won't say it out loud.
Damn, look what you made me do to my graph. What do you guys look like?
No, I'm not. So funny. Because you're laughing at me.
Yeah, hold on. We did it, but. Ew, your hands are so sweaty.
No.
Great. Ew, no one likes sweaty hands.
So? You don't have to like them, it's just kind of
I have
annoying.
sweaty hands, but they're not that sweaty right now.
Also hold it.
All right,
Appreciate it.
All right.
Nice.
Ooh, that's not good. This helps.
that,
Okay.
Got this for you.
Draw on your t-shirt, Nate. It's blue.
Daily temperature, high 62 degrees.
Nope, nothing happened.
Oh, my sling.
This is, oh yeah, this is. You just gotta go really fast. Get this quick force. Like now I can look at you whenever you hear.
okay, Nate, looking up here, thinking about what I'm writing.
Always.
Always. Great.
Is that how they do it?
Jesse,
That's actually how they do it.
thing one.
Yeah.
Do we agree that temperature will be a cyclic function, sinusoidal function?
Well, it says degrees on it, it makes sense.
What's the sign? Sign in function. What's that?
Maybe sine function.
Sign in function. Sinus. Cycle.
A cyclic function is one that cycles, goes up and down, back and forth, a pendulum on a clock is a cyclic function. A sinusoidal function is anything that has a sine-shaped curve, so sine or cosine functions all have a sine-shaped curve. They're just different parts of the sine-shaped curve.
Maybe.
So here's a question. Does temperature fall into that? What does temperature do over the course of a day? Changes. Let's be a little more specific. Cameron? It goes up and down. It goes up to a maximum, comes down to a minimum, and then what does it do? It goes back up to a maximum, and then back down to a minimum. Temperature over the short term can be modeled as a sinusoidal function. Now that sinusoidal function for a daily temperature is going to change over the course of the year. So what you're going to get is you're going to get a sinusoidal function that goes down and then goes back up again. Think of it as a sinusoidal function mapped onto a different sinusoidal function. But if we're just looking at a day, if we're just looking at what happens from this morning to tomorrow morning, and maybe even for the past few days and the next few days, you can model temperature as a sinusoidal function. It's going to reach max, it's going to reach a min. So the first thing we want to do is we want to draw a graph. We don't need negatives, so that would be a ridiculous graph. Of course I want you to draw a graph because I want you to take notes on everything that I put on the board. because I wouldn't put it on the board unless it was super important.
What about the poop one? Write down the YouTube channel right now.
There's a day. We'll start at midnight. And we'll go to midnight. Now, we know that there is a minimum of 37 degrees at 5. It doesn't really matter where we put our scale, and it doesn't matter if it is drawn to scale. Where's the next minimum?
Next.
Mark?
24 hours after.
Agreed? Because what's the period of daily temperature? How long does it take for one full cycle?
24 hours. Because that's the next.
37.
That's actually 29.
Like, why is there 29 hours?
Because from 5 a.m. the next cycle is
Oh, I
24
thought that
hours
was
from
4.
the.
It really looked like 4 from
Yeah, except that right here it says 5 a.m.
Oh.
Oh my
And
God,
since
that's
it's gonna take 24 hours to get, since it's gonna take 24 hours to get back to the next minimum, our next point is gonna be at 29. So we've got 29 comma 37 here, and we've got 5 comma 37 here. So where's the maximum going to be?
63. Nice.
That's a what? How about a where?
Up.
Cameron?
17.
Why?
Took the average of 5 and 29.
Are we in agreement?
Yes.
Then that's not sun, is it?
Well, that's a good question. Let's draw on our curve. There's the minimum. There's the maximum. Where's the center line? Macia? What's halfway between 63 and 37, Macia? That? Don't get out your calculators. I thought I heard people taking the covers off their calculators, and I was like, come on, 37 and 63? What other bits of information might we want?
The amplitude,
Say again?
amplitude,
Amplitude?
that'd be the distance from the center line to emitter max.
Agreed? Let's write an equation. We don't have quite enough information to finish it, but we can get a good long way. Here we go. Here's what we know. Y equals A. Well, turns out I didn't know much. Going okay?
Yes.
Where do I find K, Nate?
Center line.
Aha! Cool. K equals 50. Do I know frequency? Can I find frequency? How do I find frequency? Jesus? Oh, you're nodding. I thought you had it right on your finger, right on the tip of your brain.
No, I didn't have it on my TV brain.
Carson?
No clue.
No clue?
Well,
Oh dear. Oh dear. Nope. Carson just let the cat out of the bag.
my bad.
Everybody, with your partner, quick discussion. How do I find frequency? Go.
It's in here, I know. Period divided by that cell. That. It's also period divided by.
She said, hey, Mr. Armstrong, I got a question.
Yeah.
Say we multiply by 2 pi and we don't even have pi's on the that word.
Doesn't matter.
Doesn't matter. See? Check yourself.
All right, here we go. Everybody looking up front. And just so you know, I did not cheat, but I did just pull Carson's name out of my cup. So Carson, how do I find frequency? B equals? Good start. Now what?
B.
Frequency equals?
Mark didn't know I.
Write all that down.
2 pi.
Mark didn't know.
Yeah.
Over 2. Or whatever.
Over whatever.
Yeah. Whatever the right answer is. Over that.
Ryman?
Over the period.
Remember, period equals 2 pi over frequency, and therefore frequency equals 2 pi over period. Carson, what's the period of this function?
Can you move real quick?
It's not written here, it's written over there. What's the period of this function?
Yeah, what's up?
Take the endpoint.
No, don't take the endpoint to do anything, just read it off the board.
Oh, yeah, true. That is, it's there.
13. 17. 63. No. Oh, P equals 24.
Get it. He was gonna say every number.
Guys, each full cycle is 24 hours, and therefore there are 2 pi divided by 24 cycles in a 2 pi window. If I were to graph this in a 0 to 2 pi window, I would see 2 pi over 24 cycles. Now, I know what you're thinking. 2 over 24? Wait, that's 1 over 12. Woohoo! I wouldn't. Here's why. If I were to write this equation as 2 pi over 24 and say to you, what's the period of this function? Wouldn't you be able to look right at that and say, oh, look, it's 24? The nice thing about just leaving it like that is that you can just look at that equation and say, this cycles every 24 hours. If I simplify it, you'd have to do some calculation because you'd say, oh, well, it goes pi every 12 hours, but the bit is 2 pi, so I've got to double the, okay, it's 24. Less work because you don't have to simplify, and you can look at the equation and know exactly what the period of the function is. So this is the one time in your whole life that your math teacher is going to say to you, it's okay.
It's okay.
It's okay. All right. We cool with that so far?
Yes.
Now, left, right shift, my phase shift. What is my phase shift? And the answer is, Mason? No. Unless what? Could you start at 5?
Yes.
If it was a negative cosine function. Depends, because your phase shift depends on what kind of function you decide to have. Do you agree that we could start right here at a minimum, by the way, this is a minimum, and be negative cosine? Could I start here and be sine?
Yes.
Could I start here and be cosine?
Yes.
And I'm sad.
What image is
There's a pink one. Where's
Up, up.
Yeah.
What would I be if I started here?
negative?
And then I'm back to negative cosine. Here's the general rule. We can do anything we want, but we usually start with the one closest to the y-axis.
We can do whatever we want within the restrictions of the law.
Negative cosine 5. Or, if I really wanted to, because I was told, draw a sine function for this, I could say y equals 13 sine 2 pi over 24 x minus halfway between 5 and 17. 11.
You said 16.
No, you heard wrong.
That would be a perfectly acceptable answer too. But remember that if you change it between sine and cosine, you have to change your phase shift, and you have to decide whether it's negative or positive depending on which direction it's going. You're right.
So you're speaking of the teacher right now?
Huh?
God. Come on, dude.
He's practicing. He said he wanted to be a teacher.
I did. That's so disrespectful. You have a minute left, Mike. Why are you talking up?
Yeah, come on.
You know what we can do in a minute? Cosine equation. I like that.
That's true. There was like a minute and a half left. I could have thrown a whole new problem on the board and said, you can leave as soon as you show me the correct equation.
We're his honors class, not his normal class. Come on now. We should be able to do this by now.
Yeah, normal class.
Yeah.
This class?
I want this.
Look at the headline.
May I have
All right, guys, have an awesome day. See you tomorrow. Bye now.
I have a question.
Oh, yes.
Yeah, so there's a classroom assignment in Google Classroom.
Yes.
Exponential equations.
Yes.
We didn't do that yesterday.
Yes.
Leave it under missing.
Yes.
Awesome.
I'll delete it and put it back again later.
Okay, thanks.
You bet. Have a great day. Fred. How are you? Hey, Luke. Hey, Luke. How are you?
For the lab.
Stand up, you late. There you go. Aren't you glad you waited until the last minute to get it all out?
It wasn't that hard, it's just something that.
No, it really wasn't.
It's just something that I just don't know how to put it into the calculator.
Yeah, no problem, we'll talk about it. Rick, you got your stuff with you?
I just got my laptop.
Okay, get it out. Show me the ones you need help on and we'll do them. We're gonna need to do, getting that open, go shut off my live stream. One day, I forgot to shut it off, and it ran until I came in the next morning.
That's fine.
And it turns out that they don't save it if it's over 12 hours. So I lost it,
That sucks.
lost the whole thing.